If you're building on Azure OpenAI, you've hit a fork in the road. There's the Chat Completions API, the workhorse most people start with. And there's the Assistance API, which promises threads, tools, and managed state out of the box. They both talk to the same underlying models, but they hand you very different mental models and very different bills. In the next 5 minutes, I'll take both apart, what each one actually manages for you, what runs under the hood, the settings that matter, and the production gotchas that bite people who pick the wrong one. Let's get into it. Here's the one distinction everything flows from. Chat Completions is stateless. The Assistance API is stateful. With Chat Completions, the service remembers nothing between calls. Every request, you send the entire message array, system prompt, prior turns, everything. You own the conversation history, the truncation logic, and the storage. With Assistance, Azure stores the conversation for you as a thread. You append messages to a thread, then start a run, and the service manages context, tool invocation, and the back and forth loop on the server side. One puts you in control of every byte, the other trades control for convenience. Mechanically, Chat Completions is a single request and response. You build a messages list with roles, system, user, assistant, send it, and get back a completion. If you want tools, you define function schemas. The model returns a tool call. You execute it in your code, append the result as a tool message, and call again. That whole agent loop is yours to write. The upside is total transparency. You can log every token, inject retrieval results exactly where you want them, cache aggressively, and switch models with a one-line change. Latency is predictable because there's one network hop per turn. The Assistance API introduces 4 objects: an assistant with instructions and tools, a thread holding messages, a run that executes the assistant against the thread, and run steps you can inspect. You create an assistant once, then for each user you keep a thread, add a message, and create a run. The service decides when to call tools, manages the context window by truncating older messages, and exposes built-in tools like code interpreter and file search for retrieval. You poll the run status, or stream it, until it's completed. Far less code, but the orchestration is now a black box you observe rather than control. Here's where teams get surprised. First, cost. The Assistance API auto-manages context, but it still feeds the growing thread back into the model every run, so token usage and your bill can creep silently as threads get long. Second, file search and code interpreter carry their own storage and execution charges. Third, threads live in the service, so you have data residency and retention questions to answer, and there's no built-in vector store you fully control. Fourth, latency is less predictable because you're polling a run that may take several tool hops. And historically, the Assistance feature has moved through preview, so pin your API version and check the current Azure docs before committing. To make the difference concrete, here's the Assistance flow in Python. You create an assistant, create a thread, add a message, then create and poll a run. Notice you never assemble the message history yourself. The thread holds it. Compare that to Chat Completions, where you'd pass a full messages array on every single call and manage the loop by hand. The Assistance code is shorter, but remember each create underscore and underpoll call may trigger several model invocations behind the scenes that you don't see line by line. So how do you decide? Reach for Chat Completions when you need control. Custom retrieval against your own vector store. Tight cost accounting, aggressive caching, deterministic latency, or you're orchestrating with a framework like semantic kernel or LangChain that already owns the agent loop. Reach for the Assistance API when you want to prototype an agent fast. You're happy with built-in code interpreter and file search, and managed state saves you real engineering time. My rule of thumb: Start with chat completions for anything production critical where cost and observability matter, and treat assistance as an accelerator for internal tools and proofs of concept. To recap, chat completions is stateless and puts you in control of history, tools, and cost, while the assistance API is stateful and trades that control for managed threads and built-in tools. The deciding axis is ownership of state and the agent loop, and the hidden cost is silent token growth on long threads. Your concrete takeaway: before you commit, run a small spike of both with realistic conversation lengths, measure tokens and latency per turn, and only then decide. And because these surfaces evolve quickly, especially the assistance preview, always confirm pricing, API versions, and regional availability in the current Azure OpenAI docs before you ship. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.